explain concepts on a console application there rather than like a big website and all the files where we don't really need them. So let's create a new console application. Okay, make sure you choose .NET Framework and let's call it just advanced OB or OB advanced or whatever. Okay, so if you are in an interview now and someone asks you, what is inheritance? Like you've heard about it, you've done some code. Okay, so what is inheritance? Okay, uh, anyone can like imagine yourself now in an interview and you're being asked. So, what would be your answer? Like always try to expect um, a question that you are not like maybe remembering very well, but you need to remember the concept and you need to form an answer. Okay, like you have to answer. So how would you just try to explain it? What
The
what
class,
what is
the class derived from another class.
the class? What? Sorry, I didn't hear
The
the word.
class derived from the another class is inheritance.
Yeah, but okay. So,
I
but
can.
what is it? What like when we say what is it? Try to like you need to talk, right? Like so, try to say what happens in it. Okay, what could be the benefit? Okay, try to talk some from here and there. Okay, just to form and try not to like give this very short. Okay, what is inheritance? It's when a class inherits from another one. Okay, so okay, so this like although it's correct, but it doesn't seem like an answer that's going to satisfy anyone, right? Inheritance is when you inherit.
Well, you can say inheriting is when one class get the can use the attribute and method from another class or parent class.
Yeah. So notice that you need to find those keywords or the words that when you say you will feel like someone like you hit a trigger in his or her mind, the interviewer. Okay. So notice that Willie used the word reuse. Okay. So once you say reuse, it's when you reuse the methods and properties from a class in another. Okay. That's like more than halfway through. Like that's like maybe 90% of the answer. Okay. They know that what you're talking about. Okay. They know that you know what is inheritance at least. Okay. It's not like inheriting your parents when they die. Okay. So try not to form those questions, those answers, sorry, where you didn't answer anything, right? Okay, now you will see us talking about interviews very much, okay? And it may look boring or it may look like those motivational speaking nonsense, but it isn't, okay? Uh, like you may be a very, very good student and a very hardworking person. Um, you may be like better than any other interviewee, okay, in the room, but they don't know that. All what they know about you is what you're saying right now, what you wrote in your resume, okay, and what you're saying right now. So if you really can't form a sentence, if you really can't hit those keywords, okay, and feel confident, how will they know that you are a good student or a good employee or anything, right? So don't really count on like I know, knowing yourself, okay, because they don't know you. And this happened all the time. Okay, it happened all the time, and so many people they lost um, like good opportunities, and the company actually lost them. Okay, like it's a loss for both sides, not only for for the student himself, or for the interviewee himself. Just a second, please. Yeah, sorry about that. Why this thing is very okay when you work with two different screens, it just get messed up. Okay, so as Willie said, it's the reuse, okay, of methods and properties in the parent, okay, or in one, let's say in one class that you called the parent class, in other classes that you call the derived or the children classes, okay? So once you say the word reuse, you are there. Okay, so how do we achieve inheritance in C sharp? That usually they start with like the generic thing, okay? Then they go from there, okay? So now we know it's the reuse, and now we know we need to know how it's done. Okay, so how do you do it in C sharp? Do you, anyone can remember? Did you really forget those things? Okay, not sure if you are just don't if you just don't want to talk. Okay, okay, so it's very easy. Just um, the class, columns, the parent class. Okay, so let's start with a simple example where we talk about the different types of people, okay, in, for example, in an e-commerce system. So in e-commerce system, or let's say like any system, okay, you usually have customers, okay, and you have the staff, okay, people who work, okay, like at Walmart you have the staff and you have customers, okay, and staff themselves, they could be like maybe regular staff and maybe administration staff, okay. So all of those, okay, I can call them a person, right? Like whether you are a customer or you are a staff, okay, eventually you are a person, okay. So let's say that I have a class called person, okay, and you know, like whether you are a customer or a staff, you have lots of shared stuff, like your name, okay, maybe your birth date, okay, like any other information, okay, that could be useful regarding you. Okay, so let's say uh, public string name. Okay, let's say public string email. Okay, public string, or let's say date time per date. Okay, that's enough as properties. Okay, now what are the functions that could be shared among all those people, okay, or those different types of persons? Let's say that I have something like public void print name. Ah, sorry, why did I put those? This will be console.writeLine. I am a person something like the name. Okay. What about if I said public void print email? Okay. So with print email, I all what I know to do is to print the email property. Okay. Like I don't want to write anything extra. Those two functions, like you can add anything. Of course, here we are just adding, some examples. Let's say, what if I have a function that I call, okay, or let's leave this one when we talk about abstract. Okay, so this is a class person, okay, and it has few properties, few functions, okay, few methods. So now let's create a class, okay, that inherits from this one. Class, first one, let's say customer. Okay, so this one inherits from person. Now, once you inherit from person, do you need to rewrite, for example, the name and the email and the birth date? Okay. Now, before you say yes or no, you need to look at the access modifier. Okay, because not everything is shared. Okay, let's say what could be the I can't think of anything private in here, but okay, before we write anything, what are the things that you inherit from your parent? What is the access modifier of the things that you inherit from your parents? So do you inherit the public stuff?
Yes.
Yes. Okay. What else do you inherit?
Protected. Protected.
But the protected things. Okay. Actually, protected, it was like created for the purpose of inheritance. Okay. So something is not totally public and not totally private. Okay. What about private? Like if your parent has a private field or a method, do you inherit it?
No.
No. Okay. So you need to, like, those are the absolute basic things. If they want to ask about inheritance, they will start from here and go for like a more difficult thing. If you didn't know those, they won't even continue with you. Okay. So you inherit the public, you inherit the protected, and there are the other types. If you remember, we said they are very rarely used. There's one called protected internal, and there's one protected something. Yeah, honestly, I never used them. Okay, but you actually inherit them. Okay. Speaking about um, speaking about access modifiers. Okay, if I didn't say anything about a field, okay, the default. What is the default access modifier? I can't hear you, Saria, and I'm not sure if you're talking.
Private.
Yeah. So, so they said private. Do you agree? Okay. So what is the general rule when it comes to access modifiers? The default ones. So the general rule when it comes to the default access modifier is the least accessible one. Okay. So if you didn't mention what is the modifier, like whether it's public or private or protected, if you didn't mention anything, By default, it should be the least accessible one. Imagine if public was the default. Okay, that would be very like um, very bad actually, right? Like everything by default is public and accessible from everyone. Okay, the security of this code will be like extremely bad. So they do the like the opposite actually, is that the default thing is the least accessible access modifier. Now, what is the default access modifier for a class? This is just a review, okay? So
Internal.
internal, okay? In C Sharp, you can't create private classes, okay? You can create a private field, like you can say the name is private, okay? But you can't create a private class, okay? So classes have two, like two types of access modifiers, public and internal, okay? So by default, it won't be public, it will be internal. So anyone remembers the internal? What is the internal?
That we can put it in one namespace.
Yeah. So internal is internal to what? Like from its name, like internal. Internal in where? Okay. So it's internal in the namespace. So always think about the namespace as your house. Okay. So we are in a house. Imagine each person as a class. Okay. So class person, class Muhammad, class like Sulay, class Willy. Okay. We live in the same house. Okay. So internal means we can see each other. Okay. But people from the outside, from another namespace, they can't see us unless we are public. Okay. Like celebrities, for example. Those are public. Everyone can see them, everyone can access them. Okay. So in classes, you have internal and public. The default is the least accessible one, which is internal. Okay, just keep that in mind. And those are very common questions to be asked in an interview. Like, if I want to know if you know C sharp, okay, like I won't start with extremely hard things. Okay, I ask you about very deep details, unless it's like maybe a senior interview for someone who's been coding for 20 years. But if someone is a junior developer or an intern, I will ask him or her about, access modifiers. What are maybe the default ones? Different types. What is the default size of an integer, of a char, of a boolean? Okay, like those simple stuff. And this is what you need to review before going to an interview. Okay, always try to review them. And if you are taking notes now, that would be great. Like those are what the things that I need to review before going to an interview. Okay, so let's put this public again. So in general, we inherit the public and the protected, and we don't inherit the private things. Okay, so let's create. Before we create anything in person, let's create an object of customer here. Okay, so let's say customer C equals new customer. Okay, so let's say C dot name equals Mike. Okay, so you can see that the customer has access to the name field, although it's not here, it's in the parent. Okay, and that was done through inheritance. So I was able to reuse the code in the parent in my child. Okay, and I can see now, or I can say, sorry, C dot print name. Okay, I have access to properties and access to functions. So here is the output of the print name function. Okay, please make sure you are doing this, okay, because we will expand on this code now. Okay, so now if person, all what person is going to do is inherit from the parent, then it looks like a useless class. So what we usually do is to reuse some stuff and to add some stuff. So like a customer, what a customer has, okay, that for example staff doesn't. Okay, so for example a customer has a list of what, a list of, for example, orders. Okay, but let's make it string because I don't have a class order yet. Okay, just a list of his orders. Okay, this should be a class order. Okay, if you want we can create it but we are not using it now for this purpose. Okay, a customer, what a customer could have, maybe points, for example. Like if you shop at Superstore, they give you points. Okay, what a customer can have, like for example, is what we call special or premium customer. Okay, like with Costco, you have different types of memberships. So Leah, are you talking on the phone?
No, not me.
Yeah, I'm not sure if we are hacked. Like there's a strange name, which is just a number. Okay, so like we say a lot of secrets here. Okay, so anything that you think is an extra for a customer, you add it here. Okay, for example, we can have a function print orders. Okay, and for this one, for each okay, so for each order I will console.writeLine the order. Okay, so that's like the printing all the orders list. Okay, going one by one and printing them. This is something that's not in person. So if you created an object from person, okay, let's say I created person p equals new person. So person will have a name, will have all those functions here. But can I say p dot print orders? Okay. Why I can't access print orders, although it's a person? So
Customer
It is a
inherits from
customer.
person.
yeah, I didn't understand any word, but I think you are saying the correct thing. It's because the parent doesn't have access to what the child have. It's like the opposite. Okay, only the child can access the public and protected things in the parent, while the parent has no access to like anything in the child. Okay, even if it's public. So this one, let's say not allowed. Okay, so um, look at the print name now. Okay, so as you see now, we say the customer can introduce new fields, new functions. Okay, in addition to the things that you inherited. Okay, so we can agree on that. But what if the person, okay, sorry, what if the customer doesn't like something in the person, in the parent? So let's take a look at print name. Okay, so when you start this one, okay, let's see here. I am a person and my name is Mike. So what if customer class doesn't like this? Doesn't like I am a person. What if the customer class wants to say I am a customer and my name is Mike? Okay. So although I inherited my parent house, okay, like let's talk about real life, but I don't like how, for example, the backyard is designed. I want to inherit my parent house, but I want to change something I inherited.
Can we override the method
Yeah,
inside
and
the
that's what we call overriding. Okay. So if I ask you in an interview, what is overriding? Okay, like we talked about inheritance. Okay, that's nice, you know it. If I asked you now, what is overriding? How would you explain it in a very short way and meaningful way? Okay, so something you really need to practice is sometimes, or maybe most of the time, you know the answer, but you don't know how to form the answer. Okay, like it's in your mind, you know how to do it. You can create 1,000 classes with inheritance, but you really need to practice expressing your thoughts. Okay, and this only comes with practice. You need to do mock interviews. You need to just look at the question. Like there are thousands of questions out there. Just now search, go and search for C sharp common interview questions. Okay, you will have like a million one on Google. But don't read the answer. Okay, try to form the answer. It just takes like few tries, and then you will see yourself like extremely doing well. Okay, so how would you describe overriding?
modifying from inherited methods.
Yeah, so modifying or changing is the word. Like always try to find, you know, like a synonyms or like an equal word that's like the word override is pure like pure programming IT talk here. Okay, but when you say like it's about modifying the behavior that you inherit from your parent. Okay, so you inherited a function. Okay, I still want it, but I want to uh, change the behavior that my parent is providing. Okay, now how to do that in C sharp? Okay, that's usually the next question. So how we do overriding in C sharp?
put the same print
Jennifer,
name
there is a
inside?
problem with your sound. Like I really can't hear, unless you are like on a video game and you are just chatting with other players or something. Like I can see you talking, but I can't hear. I'm not sure if anyone else is hearing. And what about the rest? Like,
Sorry,
why do we
sorry.
have only the female students? I really salute you guys or girls, not the guys. I don't salute the guys. Because otherwise it would be really awkward just looking at a black screen and talking. At least now I can see some faces. Yeah, here you are today. Look, you're very handsome. Why are you hiding your face? Willie just showed us his face for a few minutes and he thought, okay, that's enough for today.
I'm still here, eh?
Yeah, like I'm like if you can really open your camera, that would be really appreciated. Like I get to see you and I get to talk with you. Otherwise, I will feel like you are doing what I did few days ago, like just starting Zoom and doing something else. You know, it's a meeting with like 100 people, so you can bail very easily. Yeah, okay. Yeah, I forgot about that. We are going back to class hopefully in October, unless we have a second wave, you know, and it's hopefully it won't happen.
No, no, no
So,
second wave.
what do you feel about it? about going back?
Well, that's okay.
Yeah.
I like the idea because here I'm alone at home, so I can practice the language. Even I forget how to speak,
Yeah, honestly, this is
and
really
that's the
important.
problem.
Yeah, there are like so much you can get when you go out, whether it's in school or in or at work, that you
Yeah.
can't really get when you're at home. And it was overall nice just to move around, and soon we will have a lot of group projects. So I'm not really sure how to do that, but like having a group, being close to your group is also a nice thing. Okay. Uh, More than just collaborating remotely. So let's see how it goes.
So, so when we go back, we will be still practicing social distancing at school.
Yeah, yeah, for sure. Yeah, we have so
So
many, like
that's
we
the
have so many
mm,
guidelines and
that
rules.
that's the part I don't really get. Like, what's the point of being there if I cannot go like with my computer to you and show you what's wrong?
Yeah. Well, we can have masks. Yeah, and like I can come see your screen from like a distance or something, but we will have masks and we will have screenings every day. Okay. And we are at the second floor, so if anyone sneezes or something, we just throw them away. And like
We keep
sneezing now is like the zombie bite. Like, do you watch zombie movies? And like having a sore throat or sneezing is like you became a zombie. Everyone will start attacking you. I don't know. It feels
even
nice and scary
the
at the same time.
cafeteria will be closed too.
The cafeteria,
Yeah.
yeah, the cafeteria will be closed, unfortunately. Well, all they really had that cooking class. Like at the end of the class, they start making incredible things. Like every day special was, I just went down to the cafeteria to see what they have, like fancy hotel style things for $10. That's the only thing I'm missing actually. Like I'm not missing my coworkers or students or just like those hot specials that I used to get there. And we
Mohammed,
don't eat for free. Yeah, like for information,
mm,
we
Kevin
pay
just
for it.
asked the question.
Sorry.
Kevin just asked the question in the chat, asking would it be a mandatory for all of us to like in person return to the
Uh,
class, or can we choose?
well, I don't know, honestly. I need to ask about that. But I think they are assuming if you can come, you should come, unless maybe you are maybe living outside the country. Like now we have the new intake. Some of them they still in India or China or outside the country. Okay,
Or
those obviously
if
have
you
to
want,
come.
Kevin, you can running before join the class, and then they when they take your temperature, you will be hot.
Yeah,
So
so I think like
14
eventually
day
you
off.
can just say I'm not feeling well and stay home. Okay, like this is the obvious thing. And I think we will be streaming for the students there. So let's say it's, yeah, exactly. Like maybe you are not feeling comfortable. You can't just stay 2 weeks without showing up, right? This is the isolation time. And I think we won't be like going full time every day. Like we will try for a day or two, see how it goes. Okay, see how many of us will die or survive. Okay, and the survivors they move to. They were a very nice Japanese show, where they start with 100 people. Okay, and there are faces one by one, and eventually those attackers they always lose. Eventually, there's a tank battle with water. Yeah, I really like that show, but they always lose at the end. So they start with hundreds, and eventually they are like five, six survivors at the end. That's how we do it here. Okay. Yeah, Hunger Games, MIT. That's exactly. Yeah, and with the cafeteria it's closed, that would be a very tough Hunger Games. Yeah, or PUBG. Yeah, no, no, just no weapons. Yeah, you can just say like Walking Dead or the zombies style stuff. Or
Or maybe the teacher can bring pizza, so as we don't have any
Yeah, and
cafeteria.
that's a good thing too. Like I will skip buying pizza. This like annual
For everybody.
ritual that I do. Yeah. Okay. So yeah, there are always pros and cons here. Okay, so we were talking about um, changing or overriding the behavior that you have in your parent. Okay, so to do that in C sharp, you need to mark the function as being overridable. Okay, that you can override this function. Okay, and to do that, you mark it with the word virtual. So here you can say that this is a virtual function. Okay, which means this one can be overridden or changed. Okay. Now there is that language that's extremely similar to C sharp, which called Java. Okay, Java, not JavaScript. Everything in Java is virtual by default. Okay, so you can override anything right away. While in C sharp, not everything is virtual by default. Everything is non-virtual. Okay, you need to specifically mark it virtual if you want to do so. Okay, so this is virtual, but it's very important to note that and to notice that it's not mandatory to override. Okay, there are other words or keywords where it becomes mandatory. Okay, virtual make it optional to override. So please keep that in mind. Okay, there's a difference between optional to override and mandatory to override. Okay, so virtual will make it optional. And now, if you don't like it, okay, you can say, okay, I don't really like what my parent has in that print name thing, so I will just override it. And you will notice that it's giving you some options. Once you say I want to override, okay, the compiler or the IntelliSense, sorry, here will give you options to what do you want to override. It will give you all the virtual functions in your parents. So you can see print name here very clearly. Okay, but what about those guys? Equals, get hash code, and toString. Like I didn't write those functions. Okay, in my
Built
parent.
in.
Built in what?
What was I forgot the.
What was that? Yeah, it was yeah. It's just the
There was
most
a lot of
important.
things.
Yeah, it's just the most important class in C sharp language. It's called something. Anyone can remember the name? The most important class where everyone is a child of that class.
Object.
What?
Object.
Yeah, the object class. Okay, so the object class is the default parent for all other classes, and everything we say, everything is an object. Okay, in C sharp. Okay, because of this class. So those are the functions that in the object class. Okay, now like this is a review, right? Like now you will never forget it. Okay, the second time that comes after a few months. Now if you ask, like if someone asks you after a year, you will remember the object class. Okay, it's very fine to like not remember now. Okay, so those functions toString and get hash code and equals, those are virtual functions in your default parent, which is called object. Okay, now I don't want to touch those now. Okay, so public override void printing. Okay, now you have more than one options. One option. You can say, okay, I want to change it. Okay, so I am a customer and my name is okay plus name. So if you want, for example, imagine, for example, that I have something from my parent. I still need it, okay? I still need it, but I want to add my own. So here I added my own, and I can still use what's in my parent, okay? What implementation is in my you can use it or you can like you just don't use it. Okay, you don't have to use what your parent is offering, but you can. Okay, so Base is, your base is your parent. Okay. Base dot print name. That means, okay, do what I want to do and then do whatever my parent is offering. Or maybe you totally don't like what is in your parent. Like you totally don't like this code, so you can just skip it. Okay. So base dot print name will go to the print name that's in your parent. Okay, and execute the code if you want. If you don't want, don't write. Okay, don't write base dot print name. So let's see now when I call customer C dot print name. So you will notice that I am a customer and my name is Mike. So now you are using the customer print name version. Okay, you are no longer using what's in your parent. What if I want to keep this base dot print? Okay, you can still hear me, right? Okay,
Now, yes.
yeah. Sorry, is we're just like just some reason Zoom sometimes just stops. Okay, so very important to know why are we doing this, not only how are we doing this. Okay, speaking about inheritance, while
This
you are
this
trying,
this base is like super.
exactly like super, yeah, super in Java. So, how many classes can you inherit from in C sharp? Like you are inheriting from class person now, and
Only one.
maybe there's a class called order, for example, you want to inherit from. Can you inherit from two classes?
No.
No. So in C sharp, multiple inheritance is not allowed. Okay, although it's technically not very correct to say this because you still have that, that parent class. Okay.
But we mean not directly, because you can have a grandfather, but
Yeah.
you
So
can
let's say, yeah, let's
you can
say
really
let's
say,
call it a grandfather because
yeah, you can.
you are the child of person and person is the child of object. Okay, that's big class umbrella that's above everyone. Okay, so technically you are inheriting from two classes, but that one just call it the default one. Okay, so don't confuse those two things. Okay, multiple inheritance in C sharp is not allowed. You are only allowed to inherit from one class. Okay, now there is a bit of a deep question here, which is why. Okay, so we know that multiple inheritance isn't allowed. Okay, now the question is why. Although it's allowed in C++, for example. Okay, there is that horrible language that's called C++. Okay, it's one of
Okay.
the strongest, fastest
I
languages.
like it. My preferred
I
one.
hate it very much. It's I hate it very much because
I don't like C, but C++ is amazing.
I like C because it's much more simple, but C++, it's just like when I learned it, I went into stuff that I didn't like. We were working in graphics and things, but C++ is extremely powerful, extremely fast,
Yeah,
like super fast, way more than C sharp, for example.
I forget
And
how to program in this language.
yeah, and it's used where you really need fast processing. Okay, like .NET won't be suitable for many programs that you see around. But it's much easier, much more like it has lots of tools, things to help you.
Yeah.
Okay,
The
so
pointers is a problem. use a
Yeah,
pointer. I never learned pro pointer. I use reference in in C++, but I never learned how to use pointer because you can
yeah,
access
and
directly the memory.
yeah. The thing is, what we call C sharp, for example, we called it a managed language where you don't manage the memory. So notice now that I created a new customer, right? And I didn't say, okay, delete the memory of the customer somewhere, okay, after you finish, for example, or do something. And for example, when you create an array, do you delete the array or free the memory of the array afterwards? Okay, you don't have to do that in C sharp. Okay, there is an engine managing the memory for you.
Yeah,
While
the
in
garbage
most
collector.
low level languages like C or C, you need to manage and control everything, especially the memory. That's why it's very powerful, but it's also harder to work with. And for example, multiple inheritance is allowed in C. Okay. But when they built C sharp, they said, okay, we don't want to allow multiple inheritance. Now, the answer is, okay, because it makes things very complicated. And they want to avoid this complexity. It makes your program very complicated. Okay. Once you have multiple inheritance, like things will go crazy very soon. And making the compiler itself, okay, the people who wrote the C sharp language will be also much more complicated if they are to allow it. Okay. So the reason not to allow it is mainly just to simplify stuff. Okay. And that's what you can answer. Yeah. Okay. So it's good now. Yeah. Just please make sure to tell me right away once you like have any disconnection. Okay. So hopefully you tried that. So we saw how to make something virtual and to make it optional for overriding. Okay. What if you try to override something that's not virtual? Okay. Let's try it out. Let's see what happens. So I will try to um, override the print email. Okay. So first thing, let's try to override it. Okay. So what's the error you are going to get here? So you can't use the word override, okay, if it's not marked as virtual or abstract for that matter. Okay. So the word override, you can't just use it to say, hey, I'm changing things here. Okay. So unless the parent function is virtual or something else called abstract, which we'll see today, okay, you can't use the keyword override. Okay. What if you didn't use the keyword override? Okay. Yeah. You don't like that. Okay. That's fine. Let me not use it. So you will notice now that there is no error. So what are we doing here? We are writing a function, okay, with the same name, like it's the same function in my parent. Okay. Notice that it worked. Okay. But you are getting a green line. Green line means a warning. Okay. There's something wrong, but it's not wrong to the point where your program won't start. Your program will start and will work. Okay. But what are you doing here? Okay. So this is something technically not very correct. Okay. You are like um, violating the concept of OOB and inheritance here. So your parent is offering a function and you are offering the same function, the same name without the override virtual thing. Okay. So what you're doing here is called hiding. You are hiding what's in your parent. Okay. And hiding is generally a bad thing. Okay. So you are hiding what's in your parent. And now we will always use this one. You won't be able to use what's in the parent through polymorphism, which what we will talk about now. Okay. So generally, this is a bad thing to do, although it works. Okay. Now there are very few rare cases where you want to use that, where you want to hide. Okay. It's mainly to avoid errors in like some old systems, okay, where there is a function, okay, that's already in the parent and you really don't want to mess things up, okay? So in rare cases, you need to do that, but you are still getting a warning. So how to just to remove that warning by using the keyword new, okay? So by using the keyword new, which has nothing to do with this new, okay, this is to create a new instance, okay, a new object. This is a different story. New here is just to avoid that warning that you keep getting, okay? So what you are saying here, like, hey, I know what I'm doing, okay? I want to hide the function in my parent for this rare case that I have. You can read about it a little bit. It's really hard to explain without a big example, but search for a new keyword in new function in C sharp. You will see some people explaining it in great detail, which I don't think is important to know. Okay, for us, it's a bit of advanced rare case. Okay, I don't really want to waste an hour explaining it, but there's a reason. Okay, it's for compatibility, sorry, and for those rare cases when you don't want to mess up the code of the people before you, okay, so you have to use new, okay. Other languages, many other languages, they don't have this functionality at all, okay. So you can say I want to hide what's in my parent without overriding. I want to totally hide it, okay, and to avoid that warning that keeps showing up, just use the keyword new, okay. So this is like a trick maybe, or let's say a question that if they ask in an interview, it's just because they want to see, do you really go in details or are you just like an average programmer? Okay. Because like if you know new, if you know hiding, if you know why you are hiding, that really means um, you are really into the details of this language. Okay. So just keep it as a side note. Okay. It's not very critical or important thing, okay, to waste all the time on it. Okay, just keep it as a note. What is a new function? Okay, what is hiding? And without a new, everything will be the same. Okay, you will just keep getting a warning that hey, you are hiding. And if you are really interested in hiding, look what it's saying. Use the new keyword. Okay, if that's really what you want to do. Okay. Okay.
I have a question.
Yeah, sure.
Why is hiding considered a bad thing?
Well, because you are really like you are losing the advantage of polymorphism, and you are losing the advantage of OOB inheritance functionalities. Like why would you hide what's in your parent? Okay, like you can just override it like this, and then if you want to use what's in the parent, you can use the base keyword. If you don't, then that's fine. Okay. So you don't have to hide it most of the time. Okay. Virtual and override, they will help you to achieve polymorphism. That means when you create when you create an object, okay, so you created an object and you said print name, okay, C sharp itself will go and search for an overrided print name and call it for you. Otherwise, it will go to the parent and call it for you. Okay, so it will do the work. So what C sharp will do, hey, this class is calling print name. Let's see, does this class have a special print name or should I go to the parent? Okay, so C sharp will do that for you. Why would you hide what's in the parent totally and like ignore it? Don't have, you can achieve whatever you want without the need of hiding. Okay, and in some languages, I'm not sure which ones. This whole concept of hiding is not there, okay? Because they thought it's not really necessary to be there, okay? So always try to like just use the regular virtual, and maybe it's like in most cases it's good to make everything virtual unless you really don't want anyone to change this function. Okay, so for example, in C sharp, they said, okay, if you want your children to change the functions, then make them virtual. Okay, but if you want them to stick to the implementation you have, then don't make it virtual. Just write it as a regular function. And now everyone will use. Okay, so when someone comes to hide what is in the parent, it's like almost a dangerous thing. Like, why are you hiding? Maybe they provided this code for a reason, and now you are totally losing this code. So maybe you shouldn't do that. Okay. This is more of a really like advanced thing without a very uh, proper example. It would be a bit hard to explain, but I thought like it worth mentioning. Okay. Maybe you could be asked in an interview or something. Okay, so we will talk about constructors and everything related to constructors, but let's do that after 15 minutes break. Okay, we'll take a bit of a break and then we'll come back very soon. Okay, yeah, see you soon.
right, guys, time to check out that third row. Me being 6 feet tall, we'll see how a grown man will fit in the back. Some of these 3 rows, it gets a little cramped. Now, to get into the back, Ford made it very easy. You're just going to push this button right at the top. Look at that. Slides forward, and that's going to give you access. Before I climb in, though, I want to just point out, very smart how Ford added the plastic foot guards down here, because that's where you're going to be putting your feet each and every time. So we're going to go ahead and climb on in. Once you're in, it's actually not too shabby. I'm going to flip up the headrest here, and there's actually a pretty good amount of room. Now, this is only 2 seats back here. That's the particular setup on this model. I guess my big gripe on many of these third rows is that the plastic that's back here on the armrest, it would be nice to have an armrest that has some softer material, but you have cup holders. And then my other big zonk is going to be no USB for the third row. You have your connectivity all the way up here, but at least one USB, I think, is mandatory, especially because you and I both know who's going to be sitting back here. Probably your kids, and when their devices go dead, that's when your life is going to become a life of misery. So that's one thing I would like to fix. Let's go ahead, though. We're going to check out that cargo area and see what kind of space we have back there. All right, guys, tail end of the business, probably the most important part of any SUV. How much junk can we put in the cargo area of the 2020 Explorer? You press the button, nice electric assist, and to be honest with you, it's on the quicker side of things. Now, a lot of times people want to see, hey, Joe, can I put anything back here with the third row up? As you can see, we have the third row up, and I'm telling you, you could get your stroller back here, no problem, lay it down. Before we put down the seats, I want to just show you this really nice compartment that Ford has integrated into the back of the Explorer.
Continue with our inheritance and our beer review. So, the thing that we want to talk about now is everything about constructors. So, first, what is a constructor? Anyone can just try to answer. Like, imagine that you have to answer and you have to come up with anything. Okay, no judgment here.
Definition of class.
The constructor is the definition of the class. No,
No.
it's very far. Okay, it's fine, but it's a bit far.
I think it is a method that is called when an instance of a class is created.
Right. Okay. So a constructor is a method. Okay, it's a function. Okay, so it's a method that's like what Harris said is called, but it's better to say it's automatically called. Okay, it will be called automatically. Okay, when you create a new instance of this class. So every time you create a new instance of this class, a constructor should be called. Okay, one constructor. You can have multiple constructors. Okay, it's not only one constructor. Okay, but there should be a constructor that is called when you create any instance. Okay, so a special method, okay, that has the same name of the class, okay, that doesn't have a return type. Okay, so you don't say, for example, public void person. Okay, you just say public person. Okay, so no return type, same name as the class, and it will be called automatically when you create an instance or an object of this class. Okay, and now you just answered the question. Okay, so that's a good thing to know, but looking here, like this is class person, I have few properties, I have few functions, I don't have a constructor. Okay, so this violates what I just said. Okay, I said that it's a function that should be called when I create an instance. So where is the constructor here? As you can see, there's no constructor. Can you see one? Okay, so where is it? How am I able to create a new instance of person and of customer if I don't have a constructor either here or here, like I have no constructors anywhere. So how is that possible?
Is
Are
empty
they hidden?
constructor?
Oh, sorry.
Okay, like Mary, go.
I said it is empty constructor.
Empty,
It
yeah, but
exists.
where is it? Like it's empty, fine, but it's empty and hidden. Okay, so it's
That's
not
what
only
Maria said.
empty, yeah. So it's not only empty, it's empty and hidden, and by default, as Jennifer said, by default it will be there. Okay, so by default, every class you create in C Sharp, there will be a default hidden empty constructor created for you. Okay, and it's internally. Okay, it's somewhere in the internal code. Okay, that you don't see, but it's there, and it will be called. Okay, is there any code in that default one? No, it's empty. Can you see it? No, it's hidden. Okay, and do you have to write it? No, it's default. Okay, it will be there by itself. Okay, now the thing that we need to know that, okay, it's hidden and empty, but what if you want something? Okay, so let's say I want to write some code in this person default constructor. Okay, so I want every time I'm creating a person, I want to say um, inside or let's say calling person constructor. Okay, so I want this statement to be printed every time I access the person constructor. Okay, instead of doing nothing. Okay, we said the default one is empty. I don't want it empty anymore. I want to write something. Okay, so I will write calling person constructor. Okay, let's see here. So here I'm creating two objects, one for person, one for customer. Okay, so we know for person it should be called for sure. Let's see what happens now. So you will notice that calling person constructor was executed two times. Although how many objects of person have I created? I only created one object of person, right? But I have two executions of the person constructor, although I created one person. Calling person constructor, then calling person constructor. Why do I have two calling person constructors, although I created only one person?
Because every time when we create a child class, it is called parent constructor.
Yeah. So every time I create a child class, okay, the parent constructor will be called by default. Okay, you don't have to do that. So it's mandatory for your code to call the parent constructor even if you are creating the object from the child. Okay, so creating the object from the child means you still need, or the code internally still need to call your parent constructor. Okay, that's first one. Let's write one in the customer. Okay, public customer. Okay, so here let's write something like calling customer constructor. Okay, let's see what happens now. So what I did is I created a customer constructor. Okay, let's see what happens. Okay. So note I have calling person constructor. This is related to this statement. To person p equals new person, right? Then I have another calling person constructor. It's with this statement, with creating a customer, with creating a child. Then the last thing I have calling customer constructor. So what can you learn from this execution, this result? What, which constructor is going to be called first? Let's
Okay.
remove this
Yeah.
one. Okay, let's remove the person. Okay, now I only have one object from the child, from the customer. Let's see what happens. So I only have what? One object from the child, the customer. Calling person, then calling customer. Okay, what does that mean? That means even when you create the object directly from the child, the constructor of the parent will be called first. So your parent's constructor is always first before your own constructor. Okay, this is extremely important to know, because if you are not aware of it, you may get in trouble. Okay, we will see one example tomorrow morning when it comes to like null types or anything. Okay, so now we know two facts. First fact, when you create an object from the child, your parent constructor will be called. Second fact, it will be called before your own constructor. Okay? Okay, that's cool. Now, what if your parent have more than one? Okay, so do you remember when we said you can create multiple versions of constructors? One that takes, for example, no argument, one that takes few of the arguments like a name, an email, one that takes everything. Okay, so let's create another person that takes a string name and also takes an email. Okay, like this one. This version takes two things. Okay, that's the version I want, because I noticed that when people are creating new persons, when my programmers are creating new persons, they usually have the name and email. Okay, so they want a constructor that takes those two right away and help them like speed up the process. So this will be this dot name equals the name you send. This dot email equals the email you send. Okay, that's what we do. And let's rewrite this one. Calling person constructor with name and email. Okay, just to know exactly where am I now. Okay, so this is construct. You may create a third one, fourth one. It's your choice. Okay, do you remember the class list? So when you create a list, you can say just new list without anything. Okay, or you can say new list and send the items right away. So it's a different way to create or to construct a list. You can send a hash set, right? Do you remember that you can create equals new list? Okay, you can create a new list and send a hash set right away. Okay, so different constructors is very common. Okay, so what do you think? Which one is going to be called now? Like when I create a customer, okay, which one is going to be called in the parent? This or this? Okay, let's see. So calling person constructor is still the first one. So by default, okay, the child will call the empty or the parameterless constructor in the parent. Okay, it won't call any other one. Okay, now now we have so many cases here. Okay, what if you remove this one? What if you no longer want the one that takes no argument, right? It's your right, okay? You don't want a constructor in person that takes no argument, okay? You want only a person constructor that takes name and email, okay? Now you have an error actually in the customer, in the child constructor. You have a problem now. Why? It's telling you that, hey, by default, I need to call the parameterless constructor in my parent, but you just removed it. I can't call this constructor anymore. Okay? And this is the only constructor I can call by default. And you just removed it. Okay? Although you have other ones, you may think, okay, why can't it call this one? Okay, there is a constructor. Can you just call this one? This won't happen. Okay, by default, it won't happen. By default, it can only call the parameterless one. Okay, so see here, there's no argument giving that uh, corresponds to the required formal parameter name of person.person. So it's telling you, hey, that you only have one constructor there, okay, and it's taking nothing. Okay, what if I remove this one as well? Or let's not remove. We may need them actually at some point. So let's just comment them. Okay, especially if you want the code and you want to play around. That even if you removed it totally, okay, even if you totally removed it, you still have a problem. It's telling you, hey, constructor of customer is not able to call any constructor in the person because you removed the empty one. So let's try to create a customer, okay, that takes 2 strings. Okay, so this is the first thing you may think about, right? Like, okay, this one in the parent, it takes 2 strings, name and email. So maybe I should just create a customer that also takes name and email and see if it works. But it's still complaining. Okay, so what did I do now? I made a matching one in the child that matches the signature of the constructor in the parent, hoping that it will work. Okay, so my guess is that, okay, this constructor should just call this one because they look the same. Both, they take 2 strings. I even named the parameters the same to help the compiler, but it didn't work. Let's see what is the error. It's telling you that there's no argument giving that it's the same error, okay? So what do you need to do here? The moment you remove the default constructor in the parent, that's when you start calling constructors in the parent manually. Okay, so here you need to say that this one will call the constructor in the parent that uses name and email. Okay, so the rule is simple actually, although it looks a bit confusing. You have that default constructor in the parent, right? Okay, as long as you have it, either hidden or not hidden, as long as you have that one that takes no arguments, you are fine. Okay, like this one. See this one? This takes no arguments, right? So as long as you have it, you shouldn't have problems. Okay, it will be called by default, whether it's hidden and empty or whether it's visible and has code. Okay, you will be fine if you have this one. Now, if you don't have this one, that's where you get into trouble, and that's where you need to manually call the constructor in the parent. Okay, So how do you call the constructor in the parent? You call it with the base keyword. So it's similar to the way you inherit. Okay, but it's for just for constructors. Okay, so colon then base, and base means like I am calling the constructor in my parent, in my base. Okay, and what are you going to send to that? Like the constructor in your parent needs two things, right? It needs two strings. So what are you sending to it? You are sending a string name and email. Of course, it doesn't care about the name of the parameter. Like you can call them whatever you want. It just cares about getting two strings. Okay, it cares about the type. It doesn't care about the name. Okay, so once you remove that default parameterless constructor, that's when you need to call things manually yourself. Okay, and now let's create one that takes only the name. Okay, let's create a third one. Let's say the third one only takes the name. Okay. Okay. Now I'm still doing fine. Okay. A problem here, like this is unrelated. Okay. Let's say this one. This calling customer construct. Okay. So let's create another one here. Public customer. Okay. This one we said only takes a name. Okay. So it's complaining. Why is it complaining? Because there's no default parameterless constructor to call, right? You need to do it manually. Okay. And you need to call, like, you can call any constructor up there. Okay. But of course, logically, okay, like the common sense is that you will call the constructor that matches the same one you have in the child. Okay, they should be matching. So if the constructor in the child only takes one string, then you should call the one that also takes one string in the parent. Okay, they should be matching. Otherwise, like, well, like it won't make sense. So here you need to say, okay, I want to call the constructor in my base that takes one string. Okay. Now you can still call the other one that takes two strings, but what are you going to send to it? Okay, like you can call the one that takes email, okay, but what is this email? Like the constructor of the child is receiving one thing, is receiving only the name. So you only have one thing to send up to your parent. Okay. So obviously you will call the constructor that takes one thing. Right? Now maybe you just want to send something like default mail dot at mitt.ca, for example. So it accepts a string, okay? It accepts any string, but this won't make sense. Like I didn't see any case like this in my life. Okay, usually people just call the corresponding one. Okay. So again, for the last time, the rule is if you disabled the, yeah, well, that's one thing before we make the review. Do you remember we said by default you have that hidden default constructor? Okay, so the thing is once you write any constructor yourself, okay, once you write anyone with parameters, without parameters, without anything, okay, you disable that empty hidden one that is provided to you. Okay, it's no longer there for you. So you need to be aware of that. You can't always say or guarantee, hey, I will write my two own constructors and I still have that hidden one that takes no arguments, right? No, you don't. Once you write any kind of constructors, this one, this one, this one. You disable that hidden default one. You disabled it. It's not there anymore for you. Okay. So that's why it's complaining. It was complaining like, hey, you disabled that empty one and I have no idea what to call now. So you need to help me with the base keyword. You need to tell me which constructor to call. Okay.
I have a question.
Sure.
So if I change the parameters name of in the base,
Yeah.
not as like capital N name, it's just if I say that's just an A, would it create an error?
No, it shouldn't. So
It shouldn't.
here,
Does that? Mm.
like N.
No, that
and
that one
E.
that one I know, but in the base, like when you're inheriting
Ah.
from child, what should
Yeah,
I
well,
match
they
the name
they
to?
they should match to what you have in the customer. They
Child
like
is
those should match to those, of course.
okay. Okay.
Okay.
Thank you.
Otherwise, like if you said N, okay, what is N? Like the compiler will say, I have no idea what is N. But when you say name, the compiler will say, oh yeah, she means this name. Okay. So those two, yeah, those should match the type and the name, of course. Okay. Let's return those. So if I return those two, now my base is still working. Okay. If I return the default one in the parent and default one in the child, okay, my base will still be working. So you have the option either to keep your code calling the default one, which is this one, or to change this behavior by using the base keyword. Okay.
Mohammed, I got one question. When we use base keyword and calling the constructor with a parameter, let's say in line 53, it goes to the person class
Right.
that matches that string name and string email. But from that constructor, if we want to print out the default, whatever we have over there, I think in console.writeLine in line 15 to 18, I think. If we want to print out that one first, can we call from the other constructor to the default constructor as well?
Yeah, well, generally, if you want something shared, okay, it's better to isolate. Like it's not very good to call a constructor from another constructor and get like a little bit lost and confused about what you're doing. Okay, it's better to isolate the code that you want. Okay, or like if you really want that, then usually there is maybe a problem in the way you are thinking. Okay, so it's better like to make constructors a bit isolated from each other and not like mix everything. So the people reviewing your code, okay, we're going to this from here to there, then they will find themselves jumping to another constructor. Okay, um, like this is not a very code style to do. Okay, and
Right.
generally people try to avoid it.
Right.
Okay, yeah, it's better to keep your constructors isolated if you have like a piece of code that you want, because like if someone forgot to call the base here, they will go right away to the default one. Okay, and that's when you maybe you lose some implementation without even noticing. Okay.
Okay. Yeah, because I've seen some codes where people have been using this keyword to call to the default constructor. So that's what I was thinking. Maybe we can call from one constructor to other constructor by using this keyword.
Yeah, this if you remember, refers to the like it can be done. Yeah, it's not like it can be done. I'm just talking about um, why should you do it? Like it's
Right.
like now we have different thoughts always when it comes to code style, but like many people don't see it as a good practice. Yeah, let me just find an article about uh, Sharp. See if you can read more about it. Like usually the why and like explanations usually is a bit of a debate. Okay, but let's see if someone this is just very confusing actually. Yeah, so it can be done as you said with this. I'm just trying to see if there's an article on why should or shouldn't you do this. So it can be just like the same way you call, but instead of base you use this. Like I just can't find anyone to explain what's going on here. Yeah, Sean Skeet usually have some. Yeah, I just need. Yeah, just keep it as a note to take about. Just maybe I can find something to refer to you. But if you are talking about this, calling this one, so instead of base, okay, this one doesn't have a base. You need to call this.
Yes,
So
like this way. Yeah.
yeah, this or yeah, but I find it confusing most of the time. Like this one. For example, this will call the one with the name. Yeah, I don't know. I just mostly I feel like it's like it can be done. The question is should or shouldn't you do it? That's the real question. Okay. So what's happening here is that I'm saying, okay, I want this constructor to call the one that takes only a string, which is this. Okay. Okay. Let's not confuse with that. Like I can see a lot of grumpy faces. Okay. We really like it's not about making you like extra confused. Like there's some C# code when you see out there, you really can barely read it. I don't think this is like a good thing to do, to be able to write complex code. Some people like to show off, like, see this code. I think the easier and the more readable is way better than like this complex one that uses every hidden feature out there. Okay, but I really like to read more about this topic anyway. Okay. Constructors. Okay, the order, the base keyword. Okay, what about we create a new class? Okay, so far we only have customer. So let's create a class staff. Okay, that also inherits from person. Okay. So staff, let's say, what do we have in staff? So let's say we have public int, let's say employee. employee ID. Okay, like all employees have IDs. You have a date time to what or when they joined. Okay, where did they join? And maybe a function. Let's override the other function, the same one, overriding one, which was public uh, for print name. Okay, let's say. Okay, so also the staff, they want to override this function that's called print name. Okay, and they don't like the implementation in the parent. So now we have two classes. Okay, we have the customer inheriting from person, we have the staff inheriting from person. Okay, both are providing extra properties and fields, or maybe they are changing what's in the parent, like how both of them are changing this function, overriding it. Okay, now let's go to like for example, let's say that I have a list or a function. Okay, static void print names. This one takes a list of person. Okay, so or to make it maybe more, to make it more like maybe more accurate, let's say this one takes customers. Okay, so we want a function that has for each for customer in customers, customer dot print name. Okay, and the same, we have one for staff. Okay, so print names, let's call it of customers. And this one is called print names of staff. This one takes a list of what? Staff. Staffs. Not sure if staffs is an award. It's just called staff list. What is the plural of staff? Is it staffs? No.
No S, just same
No,
staff.
yeah. So it can be singular and plural.
Singular is staff member.
Yeah. Okay. Yeah. Well, I named the one staff, so let's call it staff list. Okay. Okay. Staff list. And here for each staff, okay, in staff list, print the name. Okay. Now, those are two functions that are designed to print the names of either customers and or staff. Okay. And you are saying, hey, I need this because the print name function in the customer is different than the print name of the staff, is different from the print name of the person. So I need a function for each one. Now imagine you have like 10 children for person. Are you going to create 10 functions, one for each class, one for each child class? Okay, so but you still need the specific print name, right? Okay, so let's see what if I created something like this. Static void, I call it print names, and I will get a list of person. Okay, let's call it people. Oh, that's smart, like person, people. Yeah, this is pretty smart actually. Okay, so print names, people, and for each var person in people, okay, what are you going to do? Person dot what print name. Okay, now you will say, oh, that's nice, but my customers and staff are changing print name and I don't want the print name in the person. Okay, right? What did we do here? Do you remember? We overrided the print name in customer and in staff. And you will look at this code and say, hey, that's cool. You are calling print name, but you will be calling the parent one. Your object is from what? Your object is from person. Okay, so you will say, hey, that's cool, but it won't work for me. Let's see if this is true, if this won't work for you. Okay, so so we have Mike, or let's remove Mike actually. Okay, let's create a new one. So list of person, okay, let's call it people, equals new list of person. Okay, now let's start filling this people list. So people can be either what? Can be either customers or what? Or staff. So let's first create a customer, or let's say people dot add a new customer, okay, which is with the name Mike. And people dot add a new staff. What we need to create a staff. Let's create a constructor for staff that takes a string name. Okay. How do I call the one that takes and sets the name? Base name. Okay. That's how I call the constructor in my parent that will set the name. And here you don't need anything actually. Okay, so I will create a staff with the name Chris. Okay, so what did I do here? I created a list of people, and notice that I can insert customers and staff. I don't need to create an object of person to insert in this list. So a list from your parent can contain you. Okay. Okay, so a list from the parent class can contain objects from what? From the subclasses, from the child classes. Okay, now you will say, okay, that's fine, but what happens when you call print names on this list on people? Okay, so you will call this function. Okay, this function takes a list of what? A list of person, okay, which is this one, and it will call print name. And you were worried that this won't work because I don't want the print name in my parent. I want the print name in customer and staff. I want the specific one. Okay, let's see what's going to happen when I call print names. Okay, let's just remove this one, this space. Do you remember this space? This will be confusing for us, so let's remove it. Okay, take a look at that. Calling person constructor called person constructor. Okay, because we said your person constructor will be called. Okay, that's fine. Okay, what about this one? So do you remember that I called print name? Where here, this one? Yeah, in person. So I'm calling this person dot print name. Okay. So I'm calling it from person, but it was able to know the type of the object and call the specific one for you. So look, it called I am a customer and it called I am a staff. It didn't call I am a person, although the list is from what? The list generally is persons. Okay, it's people. Okay, but it didn't call the person one. It called the specific one that goes with the objects. Okay, it called the specific customer function, the specific staff function. And that's what we call polymorphism. So what do you have now is you no longer need a function for each specific thing. You can create a function that takes a list from the parent. Okay, a list that takes anything. Okay, and then you can call the functions and polymorphism. Okay, this ability of C# OOB, it will call the specific function for you by itself. So although you are using person object, okay, person list, although you are saying person.print name, it won't go to this function. It won't go to this function that's in what? In person. It will go to the function that's it's in customer. Okay, it will go to this one. And it will go to this one. Okay, although the list originally is from what? From the parent, but it will go to the specific functions in the children. And that is polymorphism. That is what you are going to lose when you do hiding, for example. Okay, so you will lose this very important aspect, okay, which is one of the fundamental aspects in OOB. Is polymorphism is although you created the list or the object reference from the parent, it will still go down there to the children, to the subclasses, and call the specific function. Now, what if it didn't find a specific function in the child, in the subclass? What if your staff doesn't have this print name? What happens here? Are you going to get a compiler error? No, because it will call the one in your father. Okay, let's see. So staff now, okay, see the staff. Staff doesn't have any specific print name, okay? So you won't have an error. It will go and call the one that you have, I am a person, okay, the one that you have in your father. So polymorphism will see, hey, do you have a specific one? I will call it for you. Otherwise, I will call it from your parent without you doing anything. Look, I didn't have to change my code here. My code is still working. My list is from the parent class and everything is working whether I have a specific one or whether I don't. Okay, and that's what we call polymorphism. It will know the type of the subclass and it will search for an overridden method down there right away. You don't have to write multiple versions of the same function for each subclass. Otherwise, it will be a lot of time consuming, a lot of code to write, and it's harder to maintain. This will be extremely important when we talk about testing, for example, when we talk about mocking. Okay, so for example, I will create a code that tests a database. Okay, but the problem is I can't test on a real database all the time, right? Like maybe you are using your personal laptop home, okay, and you are not connected to the main database of your work, okay? So you can fake a database and you want to change your code. So your code will work with a database, okay? A database, anyone, okay? So when you are at work, you will work on the real database. When you are home, maybe using your local machine, you will use a fake database. But your code will work with, hey, I just work with any database. Look at this code. It works with any person, whether it's customer, whether it's staff, whether it's a fake customer class just to fake things. It doesn't care. It works. Anything that's a person, it will work with it. Okay. And you will see this is even more clear when we will talk about interfaces. Okay. Like interfaces are mostly created for this purpose. Okay. So make sure that you understand what we are doing here. Okay, what is the point of passing a list of the parent? Okay, while still having the ability to go down there to the child and call the parent name in the child without changing our code at all. Any question? Okay. Okay. Just take a minute or two just to try it yourself. Okay. Try to override, create a list. Okay. And try it yourself. See if it's working. If it's not working, we will see if we can fix that.
Mohammed, can you just
Yep.
repeat that polymorphism concept again? I just did not get it fully.
Okay, so the concept in a nutshell is you can use a reference from your parent. Okay, like see here, for example, the reference is from the parent, the list itself. Okay, but the object, when the time of the execution is going to happen, the object will be, uh, or let's phrase it in another way. Your functions, okay, inside your classes will be called, okay, depending on the type of the actual object. So the reference is from the parent, okay, person, but the object itself is either customer or staff. Okay, so first thing, you can fit those customer and staff in a list of their parent. Okay, is it clear that we can fit children in a list of their parent?
Yes, that's right. Yeah.
Okay, so that's the first point. Okay, next point is when you are calling functions on this list, okay, the functions that are in the specific children, the specific subsystems or subclasses, those are the ones that will be called, not the function that is in the parent. Okay, so polymorphism will say, okay, this is a person, okay, but what is this actual person? It's a customer, right? Okay, so let me call the function that's in the customer. Okay, so then it will look at the next person, which is Chris. Okay, it will say, hey, I want to call the function print name in the person right away. I will see if this staff, if this child class has a function, a version of print name. Okay, and it will call it for you. But in your code, you only needed to call the function in the parent. Okay, in the execution time, it will be translated to the child class. Okay, and the function that is in the child will be called.
Okay, I got it. Thank you.
Okay, so the idea here is to pass a list of the big thing, okay, and still being able to call the specific functions in the children. That's the idea. Okay, so you pass a list of person. Yeah, does that mean you are stuck with what the person is offering? Okay, that was a yes before OB and everything. Okay, but now the answer is no. Although you passed a list of the parent, you are not stuck with what only the parent is offering. Okay, polymorphism will go deep inside each person and we'll see, okay, this person is actually a customer, so let's call the print name in the customer. Okay, then it will go the second one, hey, this person is actually a staff. Okay, so let me call the print name in the staff. Now if it didn't find the print name in the staff, now when it will call the one in the parent. Okay,
Okay, thank you.
yeah. Okay, so polymorphism is honestly one of the hard concepts to explain. Okay, it means many shapes or something in Latin, or I don't know, some odd language. Okay, but it's better explained with um, um, like an example. Okay, and this is like one of the examples where you are passing a list of the parent, but you are not stuck with the code of the parent. Your polymorphism functionality will be able to go deep inside each object and call the version in that specific type. Okay, it won't always call the version in the parent. First, it will look in the children, see, hey, do you have an overridden method? If yes, I will call this one. If no, I will go back to your parent and call the version in your parent. Okay. Okay. Hopefully, it's like the best way to do it is to try it. Okay. Once you write the code, try to remove this function once and see what happens. Keep it and see what happens. Okay. And you will learn from there. Now, what if the function is only in the child? Like, for example, print orders. This is only in the customer, right? So this one can't, like, you can't say here person.print orders. Can you say person.print orders? You can't, okay? Because this is a list of what? Person. And person itself doesn't have print orders. Some persons, some people have print orders, but not all of them. Okay, so you can't even call it here. Okay, so you need to call the function that's in the parent and it's shared with everyone. Okay. Okay, now let's look at the class person itself. Now you may say, hey, I don't want to create person. Like, do you have something called person in your system? You don't. You have either customers, staff, administrator. Okay, like no one is just a person. You always have specific title for yourself, right? So you may say, hey, this is just an abstract concept that I have. Like everyone is a person, okay? Or let's say every human is a living creature, okay? But when I call you, I don't call you, hey, living creature. I will say, hey, human, okay? Like even you can say the human itself is a concept. No one is a human, just human. Everyone is either like a girl or a boy, or like there are so many times nowadays, but you will be something. Okay, so the thing is, you may say, I don't want people to create an object from person. I don't have person. I have customers. I have staff. Okay, the person is just an abstract concept to put everyone under the same umbrella. So you can define the class itself as abstract. Okay, so you can say, hey, this is a class just to share few things and share some code and functionalities between, staff and customers. But in real life, I don't have someone, hey, person. You always say, hey, customer, or hey, staff, or hey, whatever. Okay, so you can mark it as abstract to prevent people from creating objects from that class. Okay, just now you can still have constructors. Constructors are used for initializations, but they won't be used to create an object. So let's try to create here a person. So once you create a person, you will have an error, like you can't even continue here. It will say cannot create an instance of this abstract class. Okay, so you said it's abstract, so there is no object can be created. Okay, although you can still have constructors that are used for initializing things, but they won't be used for creating objects. Okay, so an abstract class is different than static class, although both of them can be used to not create objects. Okay, do you remember the math class? We made it as static. Okay, so we made it as static because all what we want is a set of functions, the absolute value, the square root. Okay, that's a different story. Here, I want to create an abstract concept or an abstract class that is shared between a set of other classes. Okay, so as a customer, as a staff, I share being a person with everyone. Okay, so abstract classes, they can't have what? They can't have objects. You can't create an object of them. Okay, but they can create almost everything like everyone else. Okay, like you can have properties, you can have functions. Okay, you can have a function that is shared and is allowed to be modified, mark it with virtual. Okay. Now, what if you have a function that you want everyone to override? Like, what if you have a function that you want to make it mandatory to override? Okay, how do I do that? So we say to make it optional to override, we use virtual. Okay. Now to make it mandatory to override, we use abstract. So I can create a function. So let's say we have a function public. This will return a double, okay, or an int or whatever. Get, for example, let's say it's an integer. It's called get points. Okay. Do you remember like some places they give you points when you buy? So maybe like customers get points while staff get maybe extra points because they work here. Okay. So I don't have any shared code to offer, and I want to make sure everyone overrides this function. Okay. I want to make it mandatory to override and to give an implementation. That's when I mark this function as abstract. Okay, so I will mark this function as abstract, and abstract functions, they don't need an implementation. Like, because you are saying, hey, I will give you something that I need everyone to implement. Okay, I will give you a title for a function. It's called get points, but I have no code to offer. And I want to make sure every one of you, my children, will write the code for this one. I don't want you to leave it empty or anything, okay? Or like not even write your own function. So I will make it abstract to force you to have your own version of it. Okay, it's like virtual, but now you are forcing your children to have it. Okay, so if here, so
Yeah,
if you try to write a body, it will tell you that's not allowed. Like an abstract function is not even allowed to have a body. Yeah, Willie.
Yeah, so for Actra, you can have any code inside, right? That's one of the main difference.
Code
So-
where? In the parent? In the parent, you can't have any code.
But with abstract class, abstract method, no.
Yeah, are you talking about abstract class or abstract method?
Well, in abstract method, you cannot have any code inside.
No.
The
Yeah, you
brackets.
can't. You can't. Sorry, I'm hearing you can. You can't have any code inside. Like even if you want to have it empty like this, it won't allow you.
Yeah.
Okay, it won't allow you to write a body,
Yeah.
even an empty body.
For abstract class, you only
You can have everything.
but you can have only the attributes and method without code inside. in the bracket.
Attributes.
It's like a template or something like that.
Yeah, well, you can generally have like almost anything in an abstract class. Like, see here, you can have a virtual method. You can have a method without anything. You can have an abstract method. But there's something important, that an abstract method can't be in a non-abstract class. Okay? So for example, you created a class program, okay, or any class, okay? You can't create an abstract function in it, okay? So an abstract function should be inside an abstract class. It can't live in a regular class. Okay, this is also important to know. So I created a function called getPoints, and I want all my children to mandatory have a version on their own okay, of this thing. So I marked it as abstract. So now you will see your code complaining inside customer and inside staff. Like, hey, your parent made this thing mandatory and you guys are not providing any implementation. So you can have a fix here, implement abstract class, and you'll see that it wrote a stub for you. Okay, it will just throw an exception, but it's just like it's asking you. Okay, so here return anything like, okay, for example, int points equals 0. Here calculate points. Okay, and then return points. Okay, like we don't have any system now, but it's just empty code. Okay, the same story is for staff. So your parent is saying, hey, this is mandatory, so you need to do the same in staff. Like, you know, now in staff, calculate points, for example, add extra points because this member is staff. This person, let's say, is a staff member. Okay, and return it. Okay, whatever, like it could be a very complicated algorithm. Okay. So to make a function optional to override, use virtual. To make a function mandatory to override, use abstract. But abstract functions can't appear in a non-abstract class. Okay, so your class generally should be abstract. Okay, now can you create an instance from an abstract class? No, because it's called abstract. Okay, it's an abstract concept. You can't create a real thing from it. Okay, you know, like when you talk in philosophy, you will say, hey, I will try to abstract this idea. That means you are just talking about a general concept, not about a concrete thing. That's why you can't create an object from an abstract class. Okay, now abstract classes are, sorry, yeah.
Yeah, for me, abstract is like a draw. When you are going to build a building, an abstract class is like a draw.
Yeah, so I think
it's similar. So you
they
can
call them
you can
abstracts, I guess. Yeah, so it's not an actual binding. It's just like a description.
Like a draw.
A description or maybe a blueprint of a building, maybe.
Yeah, even in your draw, you don't have any furniture. So if you have the building and the furniture inside, it's like a instance of the class. But
Right,
the
yep.
abstract is like a template. It's similar than template too.
Yeah. The important thing is you can't create an actual, like you can't live in this drawing, okay? Like, because it's an abstract of a building. Okay. Now, abstract classes and interfaces are somehow used for the same purpose. We will talk again about interfaces after the break, and we will see what is the difference between an abstract class and interfaces, since they are very similar in purpose, actually. Okay, and they somehow used for the same thing. Okay, so just keep in mind, again, for the last time before the break, you can't create an instance from an abstract class, although you can still have constructors. Okay, in an abstract class, you have the freedom to either mark your functions as abstract, like this one, and now you are making them mandatory to override, and they can't have anybody. Okay, they can have parameters like int, like a, double b, okay, whatever. So they can have parameters, but they can't have body. Okay. Or you can make it optional to override. That's by using the word virtual. Or you can just create a regular function without this or this. Okay. Without virtual and without override. So you can have all kinds of different things inside an abstract class. Okay. Last thing is, can you create an abstract method, okay, inside a regular class? You can't. Okay. Abstract methods, they should appear in an abstract class. Okay. Any question? Yeah, those are new things, and a bit confusing, but we did a bit of a review. We learned a new thing. We will continue after the break. Okay, it's just need like just need some practice, and this is something that you just remember. Okay, keep it in mind. Like it's not like every system you create it will have abstract classes and abstract functions. Okay, but it's a very hot topic when it comes to interviews. They want to know if you know OOP. They want to know if you know the rules. Okay, they want to know if you know where and when to use it. Okay, like when to use an abstract class, when to use an interface, not only what is the syntax. Like you maybe you can forget the syntax and you can go right away now and search for it. Okay, it's done. But the important thing is to know when and where and why you are using them. Okay, and that's what we will talk about after the break. Okay, see you in an hour. Yeah, bye. Those abstract classes, which is the interface. Okay, so interfaces somehow similar in the way that we use them, okay, but with more restrictions. So interfaces usually supposed to represent something like can-do relationship. So do you remember when we talked about inheritance? We said like how to know if a class should inherit from another class. There is a rule that works most of the time, okay, which is the is a rule. Okay. For inheritance. How to write inheritance? Inherit. Is that how you write it? I just forgot. Yeah, let me check. Wow, correct. Okay. So yeah, it's just like I type on phones and autocomplete. I always write the first two letters, and like my mind is almost corrupt with IntelliSense and autocomplete things. Okay, so the general rule for inheritance is the is a. So ask yourself, a customer is a customer is a person. So a customer is a person. Yeah, that's a yes. So it's fine to inherit. Let's talk about order. Okay, order and customer. Okay, so the order is a person. No, so you can't create a class order that inherits from person. Okay, what about order and customer? The order is a customer. No, so it's a very critical problem to create a class called order now and make it inherit from customer. The customer has an order. Okay, so when it comes to composition, okay, there is the relation which is called has a. Okay, so a customer has an order. A customer has maybe like I know a list of ratings that he made. Okay, but the customer is not a rating. The customer is not an order. The customer is a person. Okay, so it's fine to make customer inherit from person. This is a very easy, and like it works 99% of the times. Maybe like someone can find a very specific rare case where it won't work, and you will say, hey, you are wrong here. But in general, you can just choose it. Okay. Now, um, you can create um, an interface. Okay. You can call it iPerson. So inside an interface, you generally describe what a type can do. So the the rule, the similar simple rule, you can go for a can do. So an interface iPerson should describe what a person can do. So a person can print his name, print email. Of course, we are talking about class person, like what functionalities you can have in class person. So you can have something like void print name. Okay, void print email. A person should also have integer get points. Okay. So when you are designing an interface, you are mostly talking about functionalities. Okay, and interfaces for a very recent time and for most OOB languages, first, they can't contain an access modifier. Like you weren't allowed to say public. Okay, now there is a newer version of C# where it violates most of those rules. C# 8, you can specify access modifiers, you can write code, but let's forget about this version. We are learning OOB in general. Okay, so in general, the OOB principle for interfaces that they can't have an access modifier. Like you just specify what is the return type because everything is public by default. Okay, it doesn't make sense to create a private thing in an interface. Okay. Also, in an interface, you can't create a body. So, for example, imagine that you will say, hey, print email is very similar in most of like the subclasses in customer, in staff, in admin. So let me just like, write some body here, console.writeLine, whatever. Okay, this won't work. Once you start writing any body in an interface, you will have a compiler error. It will tell you that, hey, the default implementation is not allowed. Here in Visual Studio, it will tell you if you want to do that, use the most recent version of C#, like 8 and above. Okay. I don't want you to get confused. So let's forget about that new version of C# where you are allowed to do that. They thought, okay, why not let people do it? Okay. But this is not the case in most other OOB languages. So let's learn OOB in general. Okay, just keep in mind that starting from C# 8 and above, you are allowed to violate lots of those rules. Okay, but let's learn the basic first. Okay, so you can't put an access modifier. You can write a body and an implementation for any function. Okay, and it's just to put the definitions of those functions, just to say, okay, what a person can do. What are the functions that for sure you will guarantee to have in a person? Okay, so it's not only the person can do those, the person must do those. This is the important thing about interfaces, that interfaces, if you want to inherit or implement an interface, you must, okay, it's not optional, you must provide an implementation for everything in the interface. Why? Because the interface doesn't have any body. Okay, so you, for example, you want to use this interface, then for sure you need to create what? Create a body for all the functions in the interface. They must appear in your class if you are to derive from this interface. Okay. So now you may ask, okay, what's the point? So like it's very similar to abstract class. Now the main difference that you can see in an interface and an abstract class, that an abstract class may contain implementations, while the interface can't. Okay, so an abstract class is a better option if you have some code to provide as a parent, as the base class. So if you have some code, like I have some code for print email, I'd like to share with everyone. Okay, that's when it's good to use what? An abstract class. Okay. Yeah. Also, one very like main difference is that you can only inherit from one abstract class. Do you remember when we said that multiple inheritance isn't allowed? While when it comes to interfaces, you can implement as many interfaces as you want. Okay, like 100 interfaces, that's fine. So interfaces was invented in the first place as a workaround for multiple inheritance. But you don't have any code, you don't have code structures, so you won't have the complexity of multiple inheritance when you are using interfaces. Okay, so an abstract class, okay, can inherit from an interface. Okay, so this abstract class can inherit from an interface. Now, we need actually a simpler version here. Okay, let's forget about I person and okay, let's have a general one. So let's keep this one for now. Okay, so let's create an interface. Okay, that's the interface I have. Okay, it has few methods. Okay, okay, now imagine that you created a class, okay, that wants to implement this interface. Okay, so let's create a class called my class. Okay, this class wants to inherit or implement this interface, I interface. Okay, now your code will be complaining about what? What do you think? What's the problem here?
It's not specifying method 1 and 2.
Yeah, so it's telling you, hey, you are implementing this interface, so you should create a body and implementation for each function in this interface, for each one. Okay, so you can fix it with the help of Visual Studio. So you will notice that Visual Studio will write the functions for you. Okay, and here, like, you can keep it as an exception. You can write your own code. Okay, what the compiler cares about is that you have a body, you have an implementation. Okay, as long as you have a body, that's fine. The compiler doesn't care what is the actual code you have. Okay, it cares about, is there any code or is there not? Okay, now let's remove those. So we will have the error. Okay, okay, so here what is the problem? So even if it's the class abstract, it still need to implement them. Okay, let's implement them. Okay, so changing the class to abstract didn't change anything. Okay, so even the abstract class needs to provide an implementation. Okay, what if you have something like this? So what did I do here? I said that, okay, I have the interface, it has few methods. That's nice. Okay. Now I have some code for some of those methods. Okay, I have some code, but not for all of them. Okay, like I have a code for method 2 and I wrote it here. Okay, but I don't have code for method 1. What should I do? Like I am an abstract class. I don't have code to provide at all. So if you are an abstract class and you want to avoid writing any body, okay, you can mark the function as abstract and leave the job of implementation to your children. So now when someone will inherit from my class, now that's their turn to write the code of this one. Because my parents said, hey, I don't have any implementation for this function. Okay, let's create a class. Okay, this called subclass. Okay, this one inherits from who? From my class. Okay, now it will be complaining. Now it complained only about what? It only complained about method number 1 because this one is abstract. Okay, and it's in the interface as well. So no one is providing an implementation. So eventually it will be the job for someone to provide a body for this function. Okay, so your parent, okay, avoided implementing, avoided giving a body. Okay, so your parent just handed the responsibility to you. Okay, so notice that subclass didn't have to write code for method 2. Why? Because it's inheriting what's in his parent. Okay, so you can override it, you can like maybe write another one, that's fine, but you don't have to. Why? Because your parent took the responsibility. Your parent wrote an implementation for this function. Okay, so you don't have to. You only have to write a body for what your parent marked as abstract. Okay, so things are getting a bit more complicated, but it's not really complicated once you try it again yourself. Okay, yeah, please try those 3 classes. Okay, once you get them right, the idea should be much more easy. Okay, just a minute so you can try them. Okay, any question about this? Okay, so one, like you may say, okay, why do I need to use an interface and an abstract class? You don't. Okay, you don't have, like, you can just have an abstract class like this. Okay, and have those 2 methods. Like, you won't have to create the interface as well. But it's very common practice to create the functions in an interface then leave the option for people. Either they want to implement this interface right away, or maybe they want to create an abstract class. Okay, because they have shared code to provide. Okay, and now my class can inherit not only from one interface, can inherit from so many interfaces. Okay, so at some point, if you have multiple interfaces, okay, you can't create them as multiple classes. Okay, because multiple inheritance is not allowed. Okay, so in some situations you need to use interfaces. Okay, now so iPerson, let's go back to this iPerson after we explained on the small one. Let's make person inherit from iPerson. Okay, you will notice that person has all the functions and one of them is abstract. Okay, that's fine. So if one of them is abstract, then the children should write the code somewhere. Okay, and you can see here the get points in the customer and get points in the staff. Okay, otherwise it will be complaining like, hey, there's an abstract method and no one is providing implementation. Okay, do you remember this list we created? Okay, now you don't even have to create this list from the class itself. You can create the list from what? From the interface. So you can say, I want this one to be from iPerson. Okay, and here you can say, I want to use the interface. Okay, and even if you are using an interface, okay, you are using an interface, that's fine, but you can add inside the list whatever is from this interface. Okay, so the list itself is from the interface. Now it can be passed to any function. Okay, but the actual content of the list, they can be from like a customer, because customer eventually inherits from what? iPerson, through his father. Staff is also iPerson. Okay, so they can be included in iPerson list. And here, see, like when you call person.print name, your polymorphism functionality will find the correct class and the correct version of print name and execute it for you. So, and it's very common to see functions taking an interface as a parameter. Why? Because they want you to be free to use whatever you want. So imagine I'm using here list of, for example, or imagine I'm using something called iDatabase. Okay, so I want to test a database. So I'm using an interface called iDatabase. Now I have two options. I can use a real database, because a real database is iDatabase, right? It inherits from that interface, right? Okay, or I can use a fake database, because also fake database is iDatabase. Now, then the beauty is your code won't change, because your code is dealing with what? Your code is dealing with the interface itself. Your code doesn't care if you are sending the real database or the fake one. Okay? Your code cares that you are sending something from the big interface. So it won't be changed. It will work all the time. Okay? This is extremely important when it comes to testing. Okay? Because you can't always send the real database to the function. Sometimes you need to send a fake one. Okay? Now, if your function, this one, takes an actual real database all the time, then how are you going to send a fake one? You can't. Okay? Because this function, imagine this function only takes customer. Can you say the staff now? This function only takes real databases. Can you say the fake one? No. You need to write a new code, a new function, change everything inside. Okay? But when you are dealing with the big thing, with the interface, okay? iDatabase, iPerson, iVehicle, iAnimal. Okay, you can send anything from this interface, and the code will be the same, and always the correct version will be called without you doing anything. Okay. Okay, let's take, it's 1 p.m. Let's take an exercise. Okay. So the best thing to learn something is to exercise it. Okay, so let's take an exercise, a simple one. Okay, so that's what we want for now. Okay. So we want to create an abstract class called animal. Okay. It has few properties. Like in animal, you have eat, sleep, whatever. Okay. Some animals share the ability, the functionality to fly. So, like some animals can fly, right? So they share some functionalities about flying. Some animals can share the functionality of swimming. So, for example, when you say fish, for sure you know that there inside fish there is a swim function. For sure, you can definitely say fish.swim, right? But when but this won't work for all animals. You can't say I know squirrel.swim. So they are all animals, okay? They are all inherit from the big parent animal, okay? Which has the shared things. But some animals also have like a functionality, can do, okay? Ability to fly. Some of them can do swimming, okay? Can do flying, okay? And the animal constructor will take a name and number of legs. Okay, just like to create a constructor rather than the default one. Okay, so you can use interfaces here and you can use abstract classes in the same solution. Let's see how would you design this thing. Okay, of course, start with the parent class, abstract class animal. Okay, put the shared things that you expect. Like, are you going to put the fly function inside animal? Why? Because some animals don't fly. So the fly shouldn't be in what? In the parent, in animal. Okay. Same goes for swimming. Okay. The class animal, the parent, shouldn't have a function called swim, because then you will be able to say something bird.swim. Well, birds don't swim, so there's a problem here. Okay, so let's try implementing this. Okay, I'll give you some time to finish. Once you are done, we can see what do we have. Okay. Yeah. Yeah, of course, I'm with you if you have any question. I just don't want to annoy you with any random noises or anything. Okay. So if you have anything, I'm available.
So we're just making the class.
Sorry, did you say something? Yeah, okay. It's like you are speaking under the shower or something, like so much noise and echo. Okay, so anyone is done? Um, yeah, Jennifer is done. Okay, let's. Can you share your code with us? Yeah, you just stop sharing and okay, you can share now. Okay, so you have the class animal. So the animal has name, number of legs, does fly, does swim. Okay, and okay, so this is the constructor, eat, sleep. Let's go down. Okay, so yeah. Okay, so this is a good attempt to write the parent class, but let's create like an example animal, you know, like a bird and a fish. One can fly, one can swim, and see how it will look like. Okay. Although like the Boolean is an okay solution, but it's not like a very good one. Okay. So we will see like better solutions when it comes to like now all what you are relying on is always to check the Boolean. Okay. So for example, if you want to pass a list of all the animals that can fly, okay, how are you going to pass that? You can't pass such a list. Okay. You need to pass a list of birds or a list of like fish if you want a list of animals that can swim. And with your design that relies on a Boolean only, you can't achieve something like that. Okay, but it's a very good start. Okay, try to create an a subclass. Okay, like try to create bird and fish, for example. Okay, any other solution that we can take a look at? Okay, um, Roy, are you saying something? Okay, so do you want more time to continue? You can have 2 minutes if you are almost there. Yeah, so instead of Boolean, since we are talking about a functionality, okay, you can create an interface for that. So first, okay, let's do it together. Let's create an abstract class for animals. Okay, this code is getting big, so let's share first. Okay. So let's create first a class or an abstract class, animal, okay? Okay, and as Jennifer said, we can have so public string name. Wait, is there a problem here? Oh, I'm inside another class. Okay. Okay. So, okay, public string name, public int, number of legs, and of course anything related to animals in general. We said animals generally do like a lot of shared stuff, right? Like eat, sleep. So what can we do? We can say, okay, public void eat. Okay, and here you write the code of eating. So animal is eating. Okay, and same goes for public void sleep. animal is sleeping now. Okay, so those are the things that you're gonna do. Like whether you swim or fly or crawl, you will eat and sleep, right? Okay. Of course, please don't tell me am I wrong. I am wrong. I know an animal that don't eat, or I know an animal that never sleeps. Okay, just assume that I am correct here. Okay, so that's for our animal. Okay, let's create the the subclass. Okay, so here class, let's say bird. Okay, or maybe if you want to be more specific, hummingbird or whatever. Okay, and this one is an animal. Okay, so you can make those virtual if you want to allow the children, okay, the subclasses to change them. Okay, now it's a good practice to make everything virtual unless you really have some reason not to do so, some reason to prevent your subclasses from changing the code. Okay, and like you don't want them to be able or to override it unless they hide it. Okay, now there is a way to prevent them totally from changing the code. We will talk about it soon. Okay, like what if you want a function to remain as is without even the way to change it at all. Okay, we will talk about that. Now eat, sleep, both are virtual. Animal here. Do you think we can have some abstract method here? What eat, sleep, um, what else? Animals too. Okay. Let's say that abstract. Let's say this one. Evolve. Okay. Now, if you are very religious, you may not like that. If you are not, you may. Okay. So assume it's something. Okay. So what's wrong here? What's the issue?
You're trying to write a body.
Yeah, we are trying to write a body for what? For an abstract method, which is not allowed. Okay, so if you want to keep it as abstract, like I have no code to offer you, my children, but I know like everyone evolves. And let's assume we are talking about Pokemons here. Okay, so what should the bird do? Okay, the bird should implement that abstract method for sure. Okay, and the code can be whatever you want, just a body. Okay, it doesn't matter the content of the code, doesn't matter. Okay, here like write some implementation. Okay, so the thing we talked about is that some animals share the ability to fly, but I can't put that in the animal parent, right? Because not all animals can fly. But what if you want to pass a list of all the animals that can fly at some point? What if you want to isolate all the animals that can fly and make a list of them? Okay, so since this is a functionality, a can do thing, can fly, is maybe a good practice to create one interface for that. I fly. Of course, the I is not me. I is the first letter of interfaces. Okay, it's just like a naming convention to in C#. Okay, the I. Every interface starts with I usually. Okay, so here like void fly. Void, for example, get max altitude. You know, um, with some animals can go higher than. I'm just trying to invent things here. Okay, whatever relates to flying. But when you are talking about fish, you don't say, hey, fish.fly or fish, what is the max altitude in the air? Okay. Okay, so here like some flying related methods. Okay, like you can write whatever you want. Okay, so a bird is an animal, and what is an I fly creature? Okay, so a bird is an animal, is a animal, and also can do what? Can fly. So it can implement the interface that's called iFly. Okay, here I can have it iFly, but what's the problem? Why the compiler is complaining here?
You can only inherit from one parent.
No, you can inherit from
No?
multiple parents, but this is not a class. This is an interface. You can inherit from a thousand.
Oh,
It complains because you did method.
Yeah, you can't. Yeah, exactly. Exactly. I mean, just like Saria, you can't inherit from multiple classes, but iFly is not a class. iFly is an interface. So you can inherit from a million interface. That's fine. Okay, that's one of the main reasons why they created interfaces in the first place. Because if iFly was a class, you wouldn't be able to inherit from it. Okay, so they made it as an interface. Okay, so as Miri said, it's complaining because iFly, it has some functions, right? But this function is not implementing them. So now, after bird has the fly function and get max altitude function, now the compiler is happy and is not complaining anymore.
Yeah, the issue here, as in the case of Java, that was the first language that used the interface in this case.
Mhm.
They try to use a single heresy to handle the difficulty of have a different multiple heresy. So for fix the problem, they invent the interface. In this case,
Yeah,
that's
you
the
mean
same with
the problem of multiple inheritance?
yeah, that's the same as C# did. They use the same concept as Java.
Yeah. So
So
many concepts in C# are actually taken from Java. Okay, especially the OOP concepts.
yeah,
And they
and
made the
then
languages actually very similar to each other. Then each one started adding its own things. But yeah, as I said to Saria, that creating interfaces, one of the main reasons to it was to solve the multiple inheritance issue. Okay, so now the bird is an animal and can fly. Okay, and now, for example, here you can create an like a list, for example, of I fly creatures. Okay, flying animals equals new list of I fly. And now you can put any like bears, wasps, whatever, bees, and you can use them in a function like this. But if you are relying on a Boolean, okay, just a Boolean, you wouldn't be able to do something like this. Okay, so let's continue now. Now the rest is easy. Okay, so just similar to iFly, you have the interface that's called what? iSwim. And this one has, let's say, only one function that's called swim. So when you create an animal, you will say, okay, class fish, it's an animal, and it's swim creature. Okay, so it will need to implement everything in the animal and in the swim. Okay, everything abstract in animal and everything in swim. Okay, what if you have a function, a creature that can fly and swim? Okay, let's say those yeah, some flying fish, they can really fly a bit. Okay, so let's say flying fish. Okay, so what is this? This is an animal. It can fly and it can swim. And now it's like it's everything. And now it needs to implement everything. In the fly, in the swim. Okay. Now, when you create a list of iFly, what can you put in this list? Objects from what? Of course, you can't create an object from an interface, obviously. Okay. Interfaces are not meant to create objects. So when you want to fill this list, you are going to fill it with what? What objects? Can you put fish in this flying animals list?
No, that's fine.
You can't put an object of fish class. Can you put an object of bird? Why no? So this list is for anything that implements iFly. So can you put an object of bird? Look, bird is iFly. So in that list, I can create, look, this list. So flying animals dot add new. So here you have two options. You can either add a new bird, okay, or you can add a new what?
Flying fish.
A new flying fish.
I thought you were
Because-
asking about line 232 inside the iFly. Can you switch it to bird? And I'm like, that there's no point of doing that.
Here,
Yeah, I thought.
no, lists need to be from the same type of the list, okay? But the objects inside, they can be anything that's from this list. Now, for example, I can call, okay, first element in this list dot fly. It will work. First element of this list dot get max altitude. Why is it going to fly, to work? Because if you are from iFly, if you are from this interface, then for sure you have two functions. What are those two functions? This and this. Okay, so an interface is like a contract. It guarantees that if you are from this interface, then you have all the functions in this interface. Like I am a bird, right? I am from iFly interface, right? I implement it. So for sure, I have a function called fly and mandatory function called get max altitude. That's why you can call them anywhere. You know for sure that that they are there. Okay. Okay. So that was a bit of like a big example. Okay, but like the mistakes, the terrible mistakes is first putting fly function inside animal. Why is it a mistake? Why putting a function a method for fly inside animal is a critical mistake? Because you will get to a point, as Yushin is saying, okay, you will get to a point where you can say fish dot and in the options of functions you will find fish dot fly. Hey, that doesn't make sense. Okay, so you need to either create another class parent for all the flying animals or make it an interface. Okay, you can't have it in the big parent. Okay, so that was a lot of information for one day. So I'll leave you with this code. I think we need like 2 days break every after